Okay, today is October 11, 2016, and right now in the foothills of Los Angeles at 9:45 p.m. we have a temperature of 57 degrees. The relative humidity is 76%. The dew point is 50 degrees, and we have a barometer reading right now of 30.02 inches. And that is high. It's rising, and we have high pressure being installed right in this area, and we can see the effect that high pressure is having on this moisture field as it moves through Central California. There's actually a dent right here, a semicircular dent as this moves through the area. We have high pressure right in this area, and that will ensure that this weather will not move too far south and get into Southern California. So the forecast is for possible rain in places north of Santa Barbara for tomorrow, which is Wednesday. And this is a storm system right here. We'll take a look at that. I think it's 976 millibar, something like that right here. We actually have two lows. The first low is the frontal system is right here, and then we have a low spinning here, and we have an area, a blockade that's been installed right between these two frontal systems, and that will ensure that these don't mix. We can take a look at that right now on the infrared map. We see that blockade that is separating these two systems. And we can see a lot of moisture moving through central and northern California, but none of that is producing any rain. Let's take a look at the IntelliCast map. We can see that there's no rain on the map showing up in California. We do see a few green dots right here offshore of the San Francisco area right here, but no rain in California yet. So we'll keep an eye on things. Now here is the western U.S. water vapor map. We can pretty much guarantee that there's a lot of chemtrail spraying in central and northern California. Just looking at these maps, there's no rain falling on the Doppler map, so that means that this is all being sprayed with chemtrails. And same thing with this area of moisture right here. This is the jet stream, it looks like. Got a lot of high-speed movement. Okay. All right, let's also out here on these maps, we have a disturbance right south of Hawaii. Right here, we can see that. I think this has a 20 or 30% chance of hurricane formation. We also have a disturbance here that's been blown apart. Earlier today, this disturbance right here looked a lot like this one over here with a lot of purple and blue. This was blown apart. It may reorganize itself. See a lot of clockwise rotation here. That's high pressure being installed on top of that area there. And we have this 20% disturbance over here with a 20% chance of hurricane formation. All right, let's go and take a look at the East Coast and also the Atlantic. So we have Florida right here. We have Hurricane Nicole, which is rebuilt. Now, we will recall that Tropical Storm Nicole was pushed south. It was bulldozed south and out of the way, quite a bit south, and pushed out of the way and weakened to a tropical storm for a day. Well, this storm now has 90-mile-per-hour winds. Let's go take a look at the hurricane map right here. This is the forecast for Nicole in the next few days. Right now, the storm is moving west at about 2 or 3 miles per hour. Right down here, we can see the westbound movement at 2 miles per hour. We have winds of 90 miles per hour. Let's look at right here. We've got Nicole, and with a core pressure of 970 millibars. So this storm has intensified all day long. I've been watching it, and it's now moving west. And the interesting thing here is that let's take a look at what's going on over here. I have the wide map on tonight. We have a huge area of low pressure out here. This is a gigantic area of low pressure. This is probably about 2/3 or about 75% the size of the entire United States over here. This thing could fit in about 3/4 of the continent of the United States right now. It's a giant swirling area of low pressure. And on the maps, it looks like it's about 1,005 millibar, something like that. There's a lot of high-speed flow rotating around this system. This is a gigantic vortex. And the forecast for Nicole was to start to move north and then move out to the northeast. But obviously they have a transmitter right here. We can see that all that dark, dry air, and that will maintain separation between these two systems. If a hurricane like this gets sucked into this system, that's going to intensify it. This will quickly spool up into something very dangerous. But we do see that there is a transmitter manipulation going on here. We have a sort of a right angle going on right here. None of this thunderstorm moisture is getting into, well, they've got a partial blockade going on right here. But out here, we see that things are starting to merge, and a lot of this moisture is getting pulled into this vortex, and we can see that right out over here. Okay, so we'll keep an eye on this situation. In the meantime, we do have westbound movement. This storm is rebuilt in these 85-degree waters right out here. These are very, very warm waters all through this entire area. Okay, here's the rainbow map, the IR map. We can see a very well-defined eye for most of the frames in this loop. That storm is being targeted with microwave. Go back to the big map. We can see a blast pattern right there. Okay. But yet on the hurricane map, there's nothing listed out here. There's just nothing. It's just nothing to report. That is a huge vortex. That is a lot of high-speed flow around that low. And also, it looks like there's chemtrails being sprayed in this area, and right up here as well, which is preventing this moisture from developing. So this is a sort of a gigantic dry upper level low. Okay, so we've seen these maps. No rain for Southern California. Like I say, San Luis Obispo, maybe Santa Barbara, they might get rain. This looks like a chemtrail storm to me. Just a whiteout of chemtrails. We'll have more information on that tomorrow. All right, now here's the surface analysis map. We can see those two lows that are spinning that have a transmitter that are separating the two frontal systems. That's right between these, and these are both occluded fronts, so that we've got a transmitter right behind on the core of this storm, and that's what's causing this occluded front, which is basically just a warm front overtaking a cold front. If you go back to the map and take another look at it, we can see that what's happening here, what's causing the occluded front, is the transmitter manipulation of this core. They're forcing a warm descending air into this core, and that's what's causing this big dark area, and also the clockwise rotation right up in this area. And what that's doing is that is causing warm air and against this cold front, and that's where they get that return on the map. They're showing an occluded front right here, that purple right there. This should be all blue. This should be a giant cold front. So we have two lows. One is a storm, 972 millibar. The other one's 973. Everything is moving east. Now, of course, off the west coast of California, we have, or the only coast, I could say the west coast, right here, two highs that are affecting our barometric pressure readings. So we've got high pressure. I've got right now, like I say, 30.02 on the barometer. So that's typical. When we have weather moving in, they always pump the pressure up over the area, and that will sort of that will provide a blockade, and all this weather will move north and not generate any no rainy weather for the Southern California area. So that's what we're looking at. You see that here we have a sort of a distorted incoming moisture field right here, which is being affected by that high pressure in this area. Okay, let's look at some of these other maps. The sea level pressure analysis for the nation. See high pressure out here, 1,020 millibar. Got a couple of lows indicated right through the four corner states. Got this hurricane way out over here. This is Nicole, moving west about 2 miles per hour. Here's the 500 millibar. And we see some squiggly lines right here that indicates manipulation, installing high pressure to block this storm, which is moving down the coast. So they're pumping up. All these transmitters are beginning to click on and put out their power, and that's generating returns on these maps. And we see these little squiggly lines, and that's varying degrees of high and low pressure from the transmitter manipulation at the 500 millibar level. Now, if we go to the the 300 millibar, we see the same thing to a lesser degree through all these isobars. So we'll keep an eye on the barometer. It is on the rise, and we'll do another report here probably tomorrow morning, possibly. Okay, now here is the Atlantic surface analysis map, and we can see we've got this hurricane right over here by Florida, right here. This is Nicole, and we have this huge vortex right here. This is 1,014 millibar. This thing right here. So that's that gigantic spinning low pressure vortex right there. All right. And we have, this is the ocean swell report. We've got 29-foot seas being generated by Nicole right here. Okay, well, that's it. And we'll just leave it right here. And we'll do another update tomorrow.